Teacher Hidayah.
Hi, I'm Teacher Rashida.
Hello my students, my name is Teacher Aina.
Hello, my name is Teacher Iza. So, what are we going to do today?
Today we are going to learn Newton law.
Yes, we will learn 3 of Newton law.
What is the name of each laws?
It was called first, second, and third.
Yeah, I mean, what is their name? What it is called?
The name is first law, second law, and third law. That's the name.
Oh, okay, I understand now. Thank you. Chapter 5, Newton's Law of Motion. The learning outcomes for this topic are: can define what is mass, weight, motion, and forces, can explain and understand the 3 Newton's Law of Motion, draw free body diagram as part of problem-solving strategy for dealing with dynamic problems, and apply Newton's Law of Motion usefully and consistently in dynamic problems. Hi students! What is mass? Mass is an amount of matter present in the object. It means our body has mass, and everything in the world also have the mass. Will the mass will be different when you are in the earth and on the moon? No, this is because the mass cannot change even though where are you going. The matter in the body will still the same, even though you are at here or at here, in the earth or at the moon, the mass will be the same. Next is weight. What is weight? Weight is a measure of the gravitational pull on an object. It means the gravity will influence the weight of something. Okay, now I want to ask, will the weight will be different when you are in the earth and on the moon? The answer is yes. This is because the gravity on the moon is lesser than in the earth. Within the same object, if gravitational force is increased, so the weight also increase. In conclusion, in the earth, you will have a greater weight than on the moon. Now, quick check time. Which mass will be more? A water bottle or a cat? Yes, the mass of the cat will be more. Now, what is motion? When something moves from one place to another, it means there is a motion. Did you know all the planets and everything in the universe has motion? Yes, very good. All planets move from one place to another place according to their orbit. Force, F-O-R-C-E, force. There is 2 definitions of force. First definition is about inertia. When something at rest, it will remain at rest, while the thing in motion, it will prefer in a motion. Definition 2, an impressed force is an action exerted upon a body in order to change its state, either at rest or moving uniformly forward in a right lane. Next, the inertia example. As example, when you drive a car, why you need to put the seat belt? This is because the inertia. Imagine your father drives a car and suddenly he brakes. Your body will move towards right. If you do not wear the seat belt, you will lose to the outside. It is very dangerous. So this situation said that when our body is in the motion, it will prefer staying in the motion, even though we are braking. The braking force is the outside force, and at a certain time, your body will back to normal. You need to know that the bigger the body or the object, the more inertia that they will have. Phew, Now we have finished the introduction part. Okay, students, I want you to take a deep breath before we proceed to the Newton's first law. Newton's first law of motion. Have you ever wondering why the apple on the tree do not fall to the ground like this image? The apple do not fall when there is no force make it fall. So, how to make it fall? The apple will fall when there is wind or something push the tree. Now, if a car with constant velocity, there is a red traffic light in front, or the car arrives at the road junction and want to turn to the right. What makes the car stop and makes the car change the direction? Yes, brilliant! The car will stop when the driver pressing the brake, and the car will change the direction when the driver rotates the steering. This situation related to the Newton's first law of motion. Newton's first law stated every body will remain at rest or continue to move with uniform velocity unless an external force applied to it. In these simple words, the objects will continue to do what they are doing unless some external unbalanced force acts on them. Here is the Newton's first law infographics. When the object is in the balance force or equilibrium force, the force from up and down will be the same. If the same goes to the force from right and left, they are also same. When the object having the unbalanced force, such as from the right to the left, the boxes will move from where greater force are push or pull, such as when the right force is bigger, so the boxes will move to the left. These are the application of Newton's first law, books on the table, riding the bicycle, and pushing the cart.
Okay, now let's continue with Newton's second law. Let's get started. The second law of Newton considers how a body moves when exposed to outside force. A large object will accelerate or change speed at a consistent rate when a constant force acts on it. Newton's second law gives an accurate explanation of the change that a force can make to a body motion. According to this, a body momentum changes at a rate that is equal to the force acting on it over time in both magnitude and direction. The Newton's second law of motion states that the acceleration rate of a system is directly proportional to and in the same direction as the net external force acting on the system, and inversely proportional to its mass. Why can it happen? Let me explain the concept in details. As we see here, there are two girls playing tennis. The mass of the ball is the same, but the force that the girls push with the ball is different, which is the girl 1 pushed the ball with 10 newtons, while the other girl pushed the ball with 20 newtons. According to second law, the ball at the first girl will be more accelerated than the other one. Next, we move to the second concept. We can see two men push the object. The first man is push a lorry, while the other one is push a car. The mass of the lorry and the car are different, which is a mass of a lorry is 1,200 kilogram and the car is 700 kilogram. The force of the man push is the same. So in this situation, after a man push a car and a lorry with the same force, the car's movement is more accelerated than the lorry because the mass of the car is less than the mass of the lorry. Then, by the two scenarios, we can prove that the acceleration depends on two factors, which are force and mass. The acceleration of a system is directly proportional to the force, which means that as the force increases, so will the acceleration. Besides that, acceleration is inversely proportional to its mass, which is when the mass decreases, acceleration will increase. Now, we will learn a formula of second Newton law, which is F equal to ma. What is F, what is m, and a? F is the resultant force, m is the mass of the object, and a is the acceleration of the body. The units of the resultant force is a Newton. 1 Newton is defined as the amount of force required to give 1 kilogram of mass and accelerate of 1 meter per second. So here is a quick chart for the second Newton law. As we see, we have a car, a van, and a lorry. Of course, the mass of these three vehicles different, right? If we push the three vehicles with the same force to arrive in the same direction, which vehicle use more time to arrive? Yes, a lorry use more time to arrive because it has more mass but less accelerates. Next, which vehicle arrive early? Yes, of course, the car arrives early because it has less mass but more accelerates. Good job, everyone. Okay, now we will see some example of the application of Newton's second law in real life. Firstly, a karate player breaks a slab of bricks. Since force and acceleration are inversely proportional, the player often moves their hands over the brick slab faster, right? So, this allows him to accelerate and generate more force. The bricks can be broken with enough force. Secondly is while playing football. When we kick the ball, we apply force in a specific direction and the ball will go in that direction as a reaction. Aside from that, the ball will be further away when we kick it harder to make more force. Lastly, when the car crashes, the impact force is the force acting between the vehicle and the other vehicle. When a car crash happens, the mass of the object hits the speed at which they are moving both affect how much force is applied to the accident. That implies that the amount of impact force will increase as the mass of the object affected in the accident increase. Similar to this, the amount of the impact force will increase in proportional to the car acceleration.
Do you want to take a break for a while, class? Maybe I could give you for 1 minute. Is it enough for you? Okay. So, we can proceed now. Okay, now let's start with Newton's third law. Maybe you are wondering what is Newton's third law means, right? Because you had done with first and second law. Okay, you probably know that the earth pull down on you, right? What you might not realize is that you are also pulling up on earth. So, what do you think? It is something that related with yes, gravity. You got it. Alright. For example, if the earth is pulling down on you with a gravitational force of 500 Newton, you are also pulling up on the earth with a gravitational force of 500 Newton. So, this fact is a part of Newton's law that you can understand a little bit. Now, let me tell you one more thing. Sir Isaac Newton had been stated that every action has an equal and opposite reaction for the Newton's law. So, two bodies need to interact each other to make the action react to itself. Okay, what happens when two bodies interact with each other? Yes, they will apply forces to one another that are equal in magnitude, also opposite in direction. So, do you understand with the Newton's law now? Okay, now let me explain. First is N equal of magnitude, which means that the magnitude of action-reaction pairs force is equal to each other. Second is the opposite of direction, which means that the direction of the object must be opposite to each other. Now, by having both of equal magnitude and opposite direction, so here we have the concept of Newton's third law. For example, we have here is a spaceship launching. So, as you burn fuel in a spaceship, you can cause the front of it to forward push, while you turn the exhaust gas backward, resulting in equal and opposite force. This could conclude that the pair of forces should act on two different things, but not on the same object. From Newton's law of motion, when there is a force exerted by body A on body B, there is also a force exerted by body B on body A. These forces are equal in magnitude and act in opposite direction. Such a pair of forces is an action-reaction pair. So, here the formula for the Newton's third law as example above. Alright, first we have a force on A by B. Then we have a force on B by A. So, you see here, the force is pointing each other. And that means force A equal to negative force B, because which is the force B is to the left. As you know, the condition of action-reaction pair first must be the opposite direction. Second, must act along the same line with different object. And lastly, the third one, we need to be the equal of the magnitude towards each other. Okay, now are you okay with me, students? Alright, the next part after you had understand the meaning is formula. First, we know that this Newton's third law must have force, right? So, as you had known before, is the formula for second law. Yes, it is the same formula, which is net force equal to ma. But for the second law is acceleration directly proportional to net force, which is different a little bit with the third law. Maybe if you forgot the net force, here I remind you again. Okay, net force is resolving forces by horizontally, vertically, or both if necessary. Next, what the difference from the second law is, this third law need to analyze problems of static equilibrium, where all the forces are balanced but also applies to bodies in uniform or accelerate motion. Then, when the bodies in uniform motion, so here where the force have the action and reaction force, which is the bodies have the same magnitude of forces but with the opposite direction. So, now I will tell you the difference between these three. So now, we are not focused on the picture because we know it have both action and reaction. Therefore, we focus on the elements. Alright, first, the action. Okay, what you know about action? First and foremost, in this Newton's law, what we need is two objects, and the action means that a force which is exerted by the first object on the second object. Now, we move to the reaction. When we call it reaction, so you must think that this is the react of the action. So it is mean that it must have an equal magnitude, also need to be the opposite direction with different object. Okay, last but not least, we have here is attraction. Alright, with attraction, it is have some different with action and reaction, but at the same time, this is also the Newton's law. So this attraction means that a force that is attract to the gravitational force, which is we need to have some gravity. So some gravity force here. For example, as you can see at the picture, the books are on the table, and that means we have two force, which is normal force upward and also gravitational force downward.
Now you know the three Newton laws that happen around us without us realizing it. We learn about how the ball moves, y forces, the mass and the acceleration, the opposite direction, and more. But right now we are going to make sure that you are fully understood the concept of Newton's law. So by that I will bring you to the amusement park, Sunway Lagoon. Let's go. What are we going to do today? Well, we are going to ride my favorite ride. Not a pirate ship, it's a roller coaster. Let's go. So a roller coaster, what law can be applied here? Well, you can apply it first, second, third, or three of them. Okay, so the roller coaster have different roads, okay, different tracks. So the roller coaster, the force you feel when you ride one, you cannot predict, you cannot know, never the same throughout the ride, okay? Where sometimes you're going up, you're going down, in a turn, circle, you never know, and that is what is making it so exciting. So let's just enjoy the ride and have fun with it. Let's go! So right now we are moving up to the tallest slope. What law has been applied here? Yeah, we are being pulled up by the machine to get started. It was the first law, the law of inertia. So since an object at rest remains at rest, a static roller coaster needs to be pushed, to be pulled along by a force to get going at the start of the ride. Okay? In a typical roller coaster, the first drop is always the steepest, right? So the cars right now store potential energy as they going up the track. Like right now, the potential energy that being stored then will be converted to kinetic energy when you start to fall down. By the height of the slope, it will run the rest of the ride. But then, due to the friction's unbalanced force acting on the cars, they gradually slow down, which they experience negative acceleration and then come to a stop. This is balanced force, okay, same equal force. By applying unbalanced force, you can change the motion of an object. It can make an object moving, make it object the stop to change the direction, the speed, or you could also involve the external force like brakes to stop the ride. The ride's unbalanced force also have an effect on the passengers' inertia, forcing them to change their movement. Okay, riders are pushed deeper into the seat at the bottom of the slope and then raised higher at the top of the hills. So even if the inertia may knock people out of the car, luckily the seat belt, the safety bars, function as additional unbalanced force on the passengers and keep us in our seat. So when a rider reaches the bottom of the slope, the body continues to drop. But then the chair, the seat will push you back to get your body in places. Same thing to making turns. The rider might be affected by the cars and the seat belts, and they must once overcome the inertia to stop their bodies from rocking side to side. So now we have done the first round of the roller coaster ride. So let us go again to find out the other laws. Let's go. Okay, now we are going up to the tallest slope, okay, which we will drop. What law is being applied here? The second law, which states that the acceleration of an object depends on the object mass and the magnitude of the force acting upon it. So this formula, the car on the roller coaster could probably feel the second law when it went down the slope, okay, because the cars in your body have mass. The gravity applies a force on that mass which can then cause it to accelerate down. So as it went down, don't forget there's also friction and air resistance. The rider feels the force and it moves the cars along the coaster track. The amount of force a rider experiences varies only with the acceleration of the cars along the track. So as the roller coaster speed up, positive acceleration while racing downhill, turning, the amount of force a rider feels increase. As the roller coaster slow down, deceleration, maybe due to the friction between the wheels and the track or air resistance, the forces a rider feels is off. Okay? That's why the engineers wants to make you feel more thrilling, scary ride that they hating in the coaster, adding loops and then the sharp turns. So if you want to feel more thrilling than this, you might want to go to Berjaya Times Square. Oh wait, this is not the end of the ride yet. Last Newton's law also involved in a roller coaster physics. Newton's third law of motion says for every action there is an equal and opposite reaction. So that applies to the roller coasters between the coaster cars and the track. So the gravity that pulled down the cars but being pushed back by the track. Also when the coaster cars went up, down the hill, it also created different forces on the track. This implies that when a roller coaster starts, okay, you will sink deeper into your seat like this. Okay, this is what we call the action. But then the seat is really pushing back at you, which not allowing you to fall down because of the gravity, and that here is the reaction. Okay, the same if you are going to drop. Okay, the action will push your body down forward as the gravity pull you down. But then the reaction of the safety bar will stop your body from falling forward. Okay, it's the same as the effect of the inertia on riders in the first law, right? So that's the end of the coaster rides. Do you have fun? Is it thrilling enough for you? Well, I hope you enjoyed this ride and have an idea of how the Newtons act on the roller coaster and also the other objects.
All students, can you define what is the mass, weight, motion and the force? Can explain the 3 Newton law? Okay, are you understand the 3 type of motion? Okay, good. Draw free body diagram as part of a problem solving strategy for dealing with dynamic problems. Okay, and can you apply Newton law of motion usefully and consistently in dynamic problem? Okay, good job everyone. Lastly, let me do some conclusion. The fundamental principle of classical mechanics, one of the primary field of physics, are Newton's law of motion, which are important to study. The study of mechanics focuses on how objects move or remain static in the presence of force. Motion and force play an important part in our daily activity. We should study the effects these physical aspects have on our daily life. Through the lessons, we learn more about force including friction, inertia, and gravity. We also learn about perspective and how to use basic tools to make our life better. Newton's law of motion represents the basis of many modern technologies nowadays. For example, a lot of the math in engineering mechanics is based on Newton's law of motion. I hope you all understand what we have learned today and can apply it in our real life. So that's all from us. Thank you.